is student ID G00116209, and I'm doing a breadboard simulation for my output Audible Sounder Circuit. So, and this is my Audible Sounder, which is waterproof once you put it in the rubber gasket. But for simulation, as you can see, I have my sounder hooked up, which is I can easily adjust the volume, as well as these dip switches are used to set the tone if I choose to set the tone. This output circuit, now I only have the output circuit connected to my two sources of power, which is my 24 volts DC that drives the sounder, which needs 9 to 28 volts DC. And then for circuit simulation, I'm feeding in 5 volts DC, and this will provide my high-low condition to trip my switching transistor, which is right here. And then I also have this switch so that I don't have to disconnect power. I can just apply 5 volts directly to the base of that transistor. And then the goal is to have that sounder sound when I get 5 volts when I push in the button to annunciate my sounder. So if you watch the previous videos, this output circuit will normally get wired to the alarm interface output, and that's the 3-input AND gate. So whenever that AND gate provides the 5 volts DC, that will feed into the base, trip the audible sounder. And the purpose of the transistor is to provide isolation of the two voltages, the 24 volts DC that's powering just the output circuit, as well as the 5 volt DC that's the low current, low voltage needed to put the digital circuit input that's going to the transistor. So as you can see right now, the sounder is turned off, so I'm pretty much having 0 volts DC going to my sounder. And just to test the voltages that's available so that you can see it, set my meter to 200 volts max. And I'm not sure you can see that on the I think you can see it now. So right now, so just to test the input. So once again, my input, my voltage source for this is actually 24 volts, and you should do this while recording this on a video. As you can see, I have 24 volts DC present, but the transistor is not conducting right now because it doesn't have the 5 volts DC at the base. But I do have my 5 volt DC source, and this, like I said, will actually come from the AND gate, but I do not have my AND gate hooked up right now because I'm just testing the output circuit. As you can see right there, I have 5 volts DC, but that my switch is up, indicating that the alarm is not present. Now, if I push the little push button in, it will simulate 5 volts DC triggering the base for the transistor to conduct, and then the sounder should sound. As you can see, I pushed the button in, so now it gives 5 volts DC to the base. The transistor then acts as a switch, and then that will cause the 24 volt DC to trip the the sounder. So once again, when I push in the push button, indicating an alarm condition, that's 85 volts DC to the base. The sounder sounds, and once again, this sounder will be outside the unit. I can adjust my volume to a much higher volume, but for testing purposes, I'm actually set on pretty low volume. When there's 0 volts being fed to the base, the sounder turns off. And this, as far as the ADA requirements, I could just easily swap this this sounder with with a strobe for visual indication instead. So that will conclude this video on the output Audible Sounder Circuit breadboard simulation. Thank you.